All right, so when we're talking about the chain rule, we want to identify outside function and inside function. Sometimes there's going to be more than two functions. So I see highlighted in red, I see the square root of something. I see highlighted in blue an expression of something. And then I see highlighted in yellow another square root inside. So it looks like we have 3 levels here. So you just have to do it 3 times. So it's okay. Remember, onion, right? Layers of the onion. Take the outside, then we'll take the next one, then we'll take the next one. Make sure we differentiate each level at some point. So the outside function is going to be 1/2. Oh, let me do it in red. Should I do it in red? Let's color code. I feel like color coding today. 1/2 x plus root x to the power of negative 1/2. Okay, so that's the outside. Check number 1 in red, right? Number 2 in blue is going to be this inside function. So let's multiply by the derivative of, well, x is just 1 plus, what's the derivative of root x? Remember, that's x to the 1/2. So we're going to go 1/2 x to the negative 1/2. So that's the second layer in blue. And then in yellow, we have another root x. So that's a third level. So that's times 1/2 x to the negative 1/2. Okay. Oh, I should have done it. Why didn't I do it in yellow? Did I not hit the yellow? I thought I did. 1/2 x to the negative 1/2. Okay? So outside, inside, and then innermost. And technically, we drill down all the way to until we get to a single x, and that's when we end. And so if you want to do that in black, what's the derivative of x? 1. We never actually really do that, but we drill down all the way until we get to the x by itself. Okay, so technically there would be 4 layers here, but we'll show that. I mean, we usually just do 3. So that would be where you're at if you're unsimplified. To simplify now, let's get rid of some negative. Okay, let's rewrite the negatives here as positives, and any fractional exponents, because we started with just radical signs with square root signs, we'll maybe do that as well. So let's make some sense of this. So I have a 2 on the bottom. So let's just make a big long line here. I have a 2 on the bottom for this 1/2. Okay, that's going to be on the bottom. Also, this negative brings all this to the bottom, so that's going to be root x plus root x. This is going to be on top, but then this individual one is actually, this negative here applies to the x, so that's going to be on the bottom. So this is going to be 1 plus 1 over 2 root x here. Same thing over here, right? Times 1 over 2 root x, because that's going to bring it to the denominator here, and then we'll forget about the times 1. Okay, so we don't want to leave. If we're going to simplify, we don't want to leave a product. A factored is okay. A product is okay, but this here with a fraction inside of another fraction, that's probably not okay. We want to rectify this. Okay, so we have to add this together, and then we'll take the denominator of the upper fraction to the denominator of the whole. So y prime, this is going to be 2 root x over 2 root x.
Can you please check your
1 over 2 root x.
From the high school SLC regarding a poster competition.
1 over 2 root
Again,
x.
teachers on the 3rd and 4th floor, please check your email from the high school SLC regarding a poster competition.
Wow. Okay, poster competition. Make sure we check that later. Okay. So what's this going to be? Let me just try and do it over here on the right. So this is going to be 2 root x plus 1. It's going to be 2 root x plus 1. Okay. Times 1 all over 2 root x. So let's just do one step at a time. That's all over 2 root x like that. Times 1 over 2 root x. Okay, we're getting close. We're getting close. And these steps will go pretty quick for you, right? I just want you to be able to recognize the rules that we always do, which are adding fractions, you have to have a common denominator. Multiplying straight across, top to bottom, okay? So when we multiply this, right, this is going to be 2 root x plus 1. This is going to be over 2 root x squared is going to be 4x, right? 2 times 2 is 4. Root x times root x is just x. And because this is in the denominator already, okay, remember if we write it over this, it's the same as multiplying. So it's the same as multiplying this. So probably one more step of simplification you should do is multiply the 4 times the 2. So you have 2 root x plus 1 up top, and then you have 8x root x plus root x. And that would be fine. There's no fractions inside there. There's no negative exponents. So that, I don't know what that compares to the format in the back of the book for the answers, but we'll check that here. Okay, so checking with the solution manual, I have a little bit different setup on the bottom here. So let's just take a look at that. This is the same, so we wrote the whole thing there, 1/2 times the derivative of this right here. What's the derivative of the second part? Is 1 plus 1 over 2 root x. That's what we have right here. 1 over 2 root. Okay, so 1 plus, okay, all right, so yeah, I guess let's, okay, so it is true, I have to back up, made a mistake there. So the third, yeah, okay, let's go back here. So yeah, this is an error. This is good though. Let's take a look at this. So the third level, not really a third level. Looks like a third level, but it's actually not. Why? Because if we wrote everything in exponents to begin with, it would look like this, right? Hello?
Hi. Just want to let you know your poster paper for your competition is with Ms. B.
So if we wrote this original equation in fractional exponents, then it would be easier to see. It would be easier to see that this is just it's not exactly a polynomial, but this would all be kind of on the same level. So if we took the derivative of this here, we wouldn't have to take it again. So you don't have to multiply it by the third time. If there was an x squared underneath there, then it would be a third level, but because inside is just x. Okay? So that's what changes this part. We don't have this part. Okay, so just stroke out this part, and we don't need the third level. That's a tricky one. And so then that becomes becomes 4 root x 4 root x on the bottom. 4 root x. Okay, you're right, that was a tricky one. Got it now though? So yeah, write everything in fractional exponents to begin with, and then we won't come across that one, because that one did look a little tricky. Okay? Okay, good. Any other questions from your assignment that you ran into that were problematic? Yes? 1H as well? Let's see 1H. Check it too. Let's see 1H. 1H. Okay, 4 over root 9 minus x squared. Yeah, so this one you have two options. You can do the quotient rule because it's a quotient there, or you can change this, you know, positive 1/2 as an exponent down here into a negative 1/2 if you want. So it might be easier to do product rule, I would say, or to change that into a multiplication, because actually you're not even going to have to do product rule, I don't think, just chain rule once. So to avoid the quotient rule, what you want to do is you want to rewrite this y equals as 4 times 9 minus x squared to the negative 1/2. So I did two things at once there. The first thing I did was I rewrote I rewrote the root as a exponent, fractional exponent. And then I made this fractional exponent a negative when I brought it up as a product. Okay? Okay? Now,
Students going to the SLC retreat, your best is...
so now this just becomes a power rule and chain rule situation. This one becomes quite a bit easier. And I'm just gonna, oh yeah, I'm zoomed way out here. Okay. Yeah, so if you rewrite it like this up here in the top, then it becomes, then you avoid the quotient rule, which the quotient rule can get a little sticky. So, so y prime now, the derivative is just this exponent times the coefficient in front. So that's going to be -2. We'll leave this alone for now inside there. We'll subtract 1 from here. So that's going to be -3/2. And then we multiply by the derivative of the inside function right here. So that's going to be -2x. All right. And then to simplify that, what we'll do is we'll do -2 times -2x, which is -4x. And this negative exponent here brings all this down to the bottom. It is a square root with a 2 in the denominator of the fraction there. So we have now root 9 minus x squared. And this cubed, so this cubed here can go inside or it can go outside. Doesn't really matter. So it can be like this, or it can go, or it can be inside here. It means the same thing. Okay? So it doesn't really matter. And the textbook might even leave it as a fractional exponent, but I think it'd be a good idea to write your radicals there. So, okay. Now, they probably they go a step further in this because, and I'll maybe mention this again. Here's another tip. This is why everyone's listening here. It's another tip. You probably won't see this as a final result a lot of times. Why? Because if you expand this bottom, you have root, and I'll write it all out, root 9 minus x squared times root 9 minus x squared times root 9 minus x squared, right? That's 3 times. So you actually have a chance of simplification here with this radical. So right here, this can be simplified, right? You have a square root squared. So you probably will see this further simplified. And this would be 9, just regular old 9 minus x squared times root. That extends over everything there. Okay, so you might see that like that as well. This also is a difference of squares, so you could factor that even further. But yeah, let's just check. That's h, right? Let's just check and see what the answer key says there for h, how they leave it. Okay, so they do leave it with a 3/2. That's fine. But like I say, you will often see if you have the opportunity to square a square root. Usually that's the way they leave it. So this way or this way is good. And this would be even best, because you could factor that really easily, the difference of squares there. Okay, that's for h. Got it? Okay, good. Any other questions from the assignment there?
Could you explain what we're looking for
Question
question 3?
3. Explain what we're looking for.
Because I want to get the dy over dx with the x.
Oh, yeah. Excellent. Yes. Let's talk about this notation. That's right. This is where you come across this. So this is important as well. So I might do this in another video here. Next video.